All right, let's try to finish up this section 1.6. So we are going to talk about circles for a little bit. Yeah, it looks like the rest of the lesson. This is all about circles. It's not the only time you're going to hear about circles. It's the first time, but it's not the only time. In fact, we have a whole entire chapter just on circles. Can you imagine that? Whole entire chapter just talking about circles. So, actually, this is not the first time we talked about a circle. We did talk about a circle before, didn't we? Talked about the radius of the circle, didn't we? Yeah. Yeah, so we did talk about circles a little bit, not a whole lot. So let's draw a circle. Right there. That looks like a circle. And we did give it a definition and all that kind of stuff, but let's put a special point right there. What do you think we call that point right there? It's the center of the circle, okay? So we've talked about that before. And then we drew a little line segment from the center to anywhere on the circle. Now remember, on the circle means actually on that line. So if I put a point here, is that on the circle? No, it's what? It's inside the circle, right? It's in the interior or it's on the circle. So that's on the circle. I'm sorry, that's in the circle. A point right here where that line segment ends would be what? On the circle. All right, so a bit of a difference there. So that's a radius, so we know that. Let's just write that in there, radius, even though we've talked about that before. You have another line that could go through, or a line segment that could go through the center of the circle. Now remember, the radius always has to start at the center of the circle and go to some point on the circle. This one right here, it goes through the radius, and it's very important. This thing right here, it has to not go through the radius, go through the center. It has to go through the center of the circle. But if it connects one point on the circle to another point on the circle, and it goes through the center, we have a special name for that. You probably already know that. What do you think that is? The diameter, right? So I would write it slanted, but I don't know if I can I do that here? Yeah, diameter. Tell me something about the relationship between the radius and the diameter. Exactly right. The diameter is exactly twice the radius, okay? If I wanted to, I could have done this. I could have taken this radius and then stretched it all the way to there. That would also be the diameter, wouldn't it? Okay, that whole thing. What's true about these two diameters? They're equal to each other. They're always going to be the same, okay? All the diameters of one particular circle are all the same. Same with the radius, okay? The radius on that one circle is exactly the same, no matter if I draw it from here to here, or from there to there, or from there to there, there to there. It doesn't matter. It's the same exact distance. Everybody got it? Okay. Here's another thing. Now we're getting into some stuff, at least this one anyway, that you probably have not seen before. So what if I connect 2 points on the circle, but it doesn't go through the center? What if I did that? Now, Zion, you're cheating because you already had this. Give them a shot. I don't know. You probably never heard of this, so I'd probably end up going to Zion anyway. He said it. He said it very quietly. Anybody around him here? It's called a chord, right? Okay, it's called a chord. C-H-O-R-D. All right? Now, the diameter could also be considered a chord, but it's a chord that happens to do what? Go through the center. Exactly. All right? So the diameter is a chord. Is the radius a chord? It's not. Why not? It doesn't connect 2 points on the circle. Exactly right. Okay? It connects the center to a point on the circle, but it doesn't connect 2 points on the circle. So a chord has got to hit the circle on both ends of that line segment. See the difference? So a diameter is chord. Now, is every diameter a chord? Yeah, every diameter is a chord because every diameter hits the circle at 2 points, right, at the end points of that line segment. Is every chord a diameter? No. Here's a chord right there. It's definitely not a diameter, okay? You with me on that? Here's another word that you may not have seen before. Let's go to this pink color. I like this color. make this one a little thicker. So let's just do this. Go from here to here. So what if I connected around the circle? So I'm going around the circle from there to there. It's not a straight line because it's following the curve of the circle. So it's not a straight line. So it's not a radius, not a diameter, it's not a chord. We call this thing an arc. All right? So that's the arc. It's just a curve that's part of the circle. So that's considered an arc. Let's figure out how to name some of these things. So we'll call this B, C, we'll call that A, we'll call this E, and we'll call this O. A lot of times, I don't know why, but they always like to make that center O. They don't always, but for some reason it seems like they do. And we'll call this one D. So if I just put a B right there, what does that mean? It means that point right there. If I call this A, what does that mean? It means that point right there. Everybody see that? D would be this point. O would be right here at the center. Okay? So a chord is a line segment. So if I asked you to name this chord, you would just say it's line segment BC. All right? You don't have to write the word chord in front of it. You can just say line segment BC. All right? The arc has a special little symbol for it. So we use the 2 points that it ends on. So where does this arc start and end? This pink one, the A and the E, correct? So I could put AE, but I don't put a line over top of it because that would represent a line segment. I'm going to put, what do you think I'm going to put over top of it? A little curvy thing, all right? It's a little arc. So that's how we show the arcs, all right? And we're going to be doing a lot. Not a whole lot in this chapter, but especially when we get to that circle chapter, we're going to be doing a ton of stuff with arcs. We're going to talk about the measurements of them, like this arc is equal to this angle. This arc right here is double the angle that, anyway, we're going to be doing a lot with it, all right? But right now, all we're doing is just showing you what it is, how to name it, just recognizing it. It's really not that big of a deal. Everybody good? Okay. We already said this, but I'm going to write it down. What do we say the relationship between the diameter and the radius is? So the diameter is equal to how much of the radius? 2 times the radius. All right, so that's something that they write down in the book that I think it's important to know. All right, so let's see. Yeah. All right, let's talk about one more thing. We talked about the arc. What if I started at, let me see something. I don't think I put this in my notes, and maybe they don't really talk about it, but I'm going to talk about it right now. No, I don't think they deal with it, so I'll wait until we get to the circle chapter to talk about what I was thinking of in my head. I was going to do major arc, minor arc, remember that stuff? Yeah. But I don't think you need to know that right now, so we'll leave that. I think we basically have one more thing, then we'll do an example. What if I went from A all the way around the circle back to A again? That's the circumference. It's the distance around the whole entire object, okay? So circumference is kind of like perimeter, isn't it? All right? It just happens to be the perimeter of a what? A circle. And a circle is a little more, it's a little different, than something with all straight sides. So we give it a different name. So we call the perimeter of the circle, we call it the circumference. Did I spell that right? Circumference. Yeah, that looks right. So that's the distance around the whole entire circle. So if I start here and I go all the way around back to where I started, that's the distance around it. It's the perimeter of the circle, really. That's what circumference is, the perimeter of a circle. We have a little formula. Since we know radius, we know diameter, and all that good stuff, we have a little, let's put it over here so you can see it better. So we have a formula for circumference of a circle. All right? I'm going to write it in 2 different ways. Some people write it like this. Pi, and I'll talk about pi in a second, times the diameter. All right? So that's what it is. Or you could write it, circumference equals, what did we say the diameter was? 2 times the radius, right? So instead of writing it as diameter, I could write it with radius in it. So I could put a pi, and then instead of d, what can I write? 2r. But this looks, I mean, that's fine. Okay, it's perfectly fine. But we don't normally write it like that. Okay, when we have something like this, we usually put the number out in front. Okay, so we're going to put the 2 out in front, then we'll put the pi, and then we'll put the radius. Is that all right? So the 2 times r is the diameter. So really, it's the same exact equation, isn't it? Same formula. It's just one deals with the diameter and one deals with the radius. Okay? What in the world is pi? Yeah, we all know that, right? So pi, is it equal to? Yeah, we'll talk about that too. Is it exactly equal? And I put pi, and I say 3.14. Put it squiggly equals. What's that mean? It doesn't mean congruent. It's 2 squigglies, one on top of each other. Congruent is an equal sign with 1 squiggle. It's approximately, yeah, about. That's a good way to put it. Okay, it's about or approximately. That's how we would say it in math, okay? So it's approximately 3.14. Why do I say approximately? Why isn't it exactly 3.14? It's an irrational number. Good, I like that. It's an irrational number, okay, and it keeps on going forever and ever. It doesn't repeat, though, all right? You know how, like, 1/3. 1/3 is what as a decimal? 0.333, and it repeats, doesn't it? All right, it stays 3s forever. You put that little line over top of it, right? We've done that before. But this is an irrational number, and it doesn't repeat, but it keeps on going forever and ever. Years ago, I used to have this sign, kind of a sign. It was like this wide, but it was really long. It didn't wrap around the whole room, but it would probably go maybe halfway around the room, and it had like, I don't know how many. I don't think it had 100, but it had a whole bunch of decimal places for pi. The only way I have it memorized is 3.14159. You could keep on going and memorize further, okay? I saw a TV show years and years ago. This TV show, I forget what it was called, but the gist of the show was kind of like a game show, and they would give the person like a task to learn how to do, and they'd give you a week to do it, all right? So one time they had to learn how to play the guitar, right? You had to get people that didn't know how to play the guitar. You had to be able to play the song in like a week or something. They had all these different things you could do, like a Rubik's Cube, right? Somebody that didn't know how to do a Rubik's Cube, they give them a week, and they'd have to see if they could solve a Rubik's Cube in a week. So one of the things was to memorize pi to 100 places. So they would have these people and say, okay, here's pi, 3.14159, and, you know, it's on the computer. You could always go to the computer. I don't know if they gave them a piece of paper. I have no idea. It was a long time ago. But they'd have to memorize pi to 100 places. And so they would come the next week and rattle it off. And a couple people got it, and a lot of people didn't get it. It's kind of interesting. I had a student a long time ago at my old school that I used to teach, and he had pi memorized to 100 places. We followed along. We had pi written out on a piece of paper, you know, to like 100 places. And he would go on and on and on. And at some point, he would just say them so fast, we kind of lost track anyway. But it's a fun skill, I guess. But there's no reason for it. There's absolutely no reason. Because when you're measuring things, I mean, I have it memorized 3.14159. And if I really wanted to, I probably could try to memorize even further. But there's no use to know really past maybe 3 or 4 decimal places. Because we don't have any instruments that can measure that precisely anyway, right? Like when you think of millimeters, they're really, really small, right? And that's only, 3 decimal places of a meter, right? But if you go out 5, 6, 7 places, you don't even have anything, like normal things. Maybe in some scientific laboratory or something, you can measure things, you know, to these like micrometers or whatever it is. But we don't have anything that can measure that precisely anyway, all right? And so there's really no use into memorizing a whole bunch. That's why we stick with 3.14, right? That's why we just stop right there. And that's why it's approximately. So technically, you'll see this. And then that sign that I had that wrapped around the room, at the very end of the sign, it had a ... Now, there's a couple places, if you look up pi to a whole bunch of places, there's a couple places where some numbers repeat. Sometimes you'll see a couple 5s next to each other, sometimes a couple 2s next to each other, whatever it is. But it never continues that pattern. All right, it might repeat a couple times, but that's it. It'll never repeat a certain pattern. But where did they get that number from? Did somebody just sit around and like, 3.14, that's kind of cool? Well, no, they didn't. Basically, what they did is this. And I used to have, maybe for my other geometry classes I might do this, I don't know. But I used to have a circle in cardboard, and then I had a piece of string. And what I would do is take that cardboard circle, and it was about this big, all right? And I would wrap the string around the circle. And then I'd measure, where it stopped, and then I'd measure the string, right, to find the distance. And so what is that? What did I find then? The distance around the circle. I just found the circumference, didn't I? All right. So I can measure the circumference, can I? All right. So I wrap a string around the circumference, okay, stretch it out, measure the length of the string. And then I can measure the diameter of that same circle. So if I took the circumference, I'll tell you what, let's do this. Let's do a little bit of algebra. Circumference equals pi times the diameter. Now, again, I know what pi is, but let's pretend we didn't know what pi is, all right? And we wanted to solve for it. What's the math? One little step. What's the math to get pi by itself? Divide by the diameter. That's right. Everybody see that? So what is pi equal to then? The circumference divided by the diameter. Very good. So I could find and the cool thing is that it doesn't matter how big the circle is. Let me see if I still have it. Yeah, I did. Look at that. I still got these things, and I have these in my drawer right there. These are just these little cups because they're all different circles, right? So what I used to do, I used to take a piece of string, wrap it around there, okay, measure it out, find the diameter of this, measure the diameter of this little cup, measure the circumference of that circle, and then divide, all right? And I would always get 3 point, what do you think? Well, you'd think you would, but measuring with a piece of string and measuring with a ruler is not the most accurate thing in the world. But I'd always get just a little bit more than 3, all right? So it wasn't exactly 3.14. If you were like super, super accurate and you had some kind of device, right, that could measure that precisely, sure, you would get 3.14. It doesn't matter if you had a big old giant circle or a little tiny circle. Every single time, pi is the circumference divided by the diameter, okay? So basically it's saying this, that the circumference of a circle is always a little bit more than 3 times the diameter. Does that make sense? All right, so any circle, if you walk around the circle, it's always a little bit more than 3 times walking straight across the center of the circle. Does that make sense? That's where pi comes from, all right? And again, it's kind of precise, but it's just a little bit more than 3 times. In fact, pi is actually found in the Bible. I should have this memorized, and I forgot I was doing this lesson today, so sometimes I look it up. You can look it up. Let's look it up. You won't be able to see this on the YouTube screen. There we go. So, pi in the Bible. I'll talk about the 22/7, by the way. Oops, let's do this. Is math, what's circumference? Where's the Bible verses? I don't know. Let's see what that says. There's a whole bunch of values for pi. All right, there we go. And he made a molten sea, 10 cubits from one brim to the other, and it was round all about. So 10 cubits, whatever that measure is, whatever a cubit is. I think I heard a cubit. This may be wrong. Don't test me on this, but I think a cubit was like from the elbow to the tip of the fingers of the king at the time. So every time we had a different king, or they had a different king, a cubit could be different. That's what I've heard. I don't know. You can always look it up. You got Google, right? So I think that was a cubit. So anyway, maybe it was bigger. Maybe that was some other kind of unit of measurement. But whatever a cubit is, all right? So 10 cubits from one brim to the other. So what is that? What is that measurement? It's a circle from one part of the brim of it to the other. What are they showing right there? That's the what? That's the diameter, right? So they don't use the word diameter in the Bible, but that's what it is, isn't it? Everybody see that? And then it says it was round all about. So it means, what was it? What kind of shape was it? Circle. And its height was 5 cubits. We don't have to worry about the height. But then look, it said a line of 30 cubits did compass it round about. Now, this is probably Old English, Old Bible English kind of thing. But what does that mean? It means it was 10 across. And then, what does it say? 30 cubits did it compass it round about. So that means around the circle was 30. So some people actually use this, and there's debates. You could probably look it up on there. Some people say, well, the Bible is not accurate because it says that it's 30 around when it should be, like 31.4 around, And like, oh, come on. The Bible is not going to go 1.4, in the Bible back then. And people try to dispute the Bible by using that passage, which is kind of silly, I think. But people they do that. So right there in the Bible, and I think there's a couple other verses in the Bible that talk about the distance around the lake or a pond or the sea or something like that, and it was circular, and it was 3 times what it was straight across, right? But that's one example of pi in the Bible, which I think is kind of interesting. Has anybody got a calculator in front of them? Okay, get a calculator out. So, Hunter, you said 22 sevenths, right? Yeah, and that's fine. We learn that all the time, don't we? If we want to write it as a fraction instead of a decimal, we write 22 sevenths. So put that in your calculator and tell me what 22 sevenths is. Two decimal places. Give me a couple more decimal places. 285? Okay. Do you have a pi button on your calculator?
Oh, yeah, I know.
Yeah. We'll make that squiggle right there. So it's 3.14159.
285.7.
But it is 14159 though, right?
No, it says 285.
For pi?
Yeah.
No, it doesn't. It says you did it right.
3.145.
Yeah, exactly. So that's pi right there. That's what pi is. This is what 22 over 7 is. Is 22 over 7 exactly the same as pi?
No.
It's not. It's pretty close. Up to the second decimal place it is. Even if you round this, well, actually, if you round that one, that would be a 3, wouldn't it? If you round that 1, that would be a 2. So really, after the second decimal place, it changes. So 22 sevenths is just an approximation of an approximation, okay? But it's pretty close, though, right? That's the closest fraction that we have, I think. Or it's a fraction that's pretty close to 3.14, which is pi, all right? So that's why they use 22 sevenths. But is it exactly pi? No, it's not, all right? 3.14159, up to the second decimal place, yeah, it is, all right? And it's fine, if you're doing stuff and you're using fractions and you use 22 sevenths, no big deal. But we're using calculators now anyway, aren't we? So we might as well just use the pi button on the calculator. All right? All right, let's do an example. And then we'll be done. Let me get rid of all of this. And let's put a circle in here. And so this is the kind of stuff that they're going to ask you on your homeworks in this little section. All right, so here's what they give you. They give you a circle. They tell you the radius. Well, actually, nope, they don't tell you the radius. I'm going to put R for radius because we don't know the radius. But they tell you the circumference, and they tell you it's 10 centimeters. Okay? So they tell you the circumference, but you have to find the radius. All right? Why don't you give it a shot? So you got to find the radius of that circle. They tell you the circumference, okay? All the way around, it's 10. But you need to find the radius of that circle. Even if you don't have a calculator, just do the math as far as you can, right? There's a little bit of algebra that you have to do. Do it as much as you can, and then we'll stick it in the calculator at the end if you don't have a calculator on you. So A, we're going to find the radius. So do you have a formula that you're going to use? Yeah, what's the formula that has circumference and radius in it? Circumference is 2 pi r, right? Yeah. So that's the formula that we're going to use, okay? Now you could use pi times diameter, but then you'd have to find the diameter, and then what would you have to do to get the radius? Divide by 2. You could do that, that's fine. But I'm just going to use the formula that I know that's got radius in it, right? It's a little easier. So now what can I plug in here? What do I know? I know the circumference, so I'm going to put a 10 right there for circumference. What about this? I know what 2 is. I know what pi is, correct? And all I got to do is find what? R. So let's do some algebra now. So we just plugged in, all right? Did I use that phrase before, plug and chug? No? I had a professor in college who used to say that all the time, plug and chug. I always thought that was kind of funny. So I use it all the time, ever since I've been teaching. So what is the plugging? The plugging is you put the number into the formula, okay? You plugged it in, right? Now you chug, you do the work, all right? So that's all it is. Just doing the algebra is the work. So I want to get r by itself. So what do I have to get rid of? The 2 and the pi, right? So how do I get rid of that 2 and that pi? It's being multiplied, so I divide, right? So I divide by 2 pi. I come over here and what? Divide by 2 pi, all right? 2 pi's cancel out, so r equals 10 over 2 pi. That doesn't look very pretty, right? So we do stick it in a calculator. If you put that into a calculator, you get approximately 1.59. And this is in centimeters, so make sure that you put the units, okay? So that's the radius of this circle right there. The radius would be 1.59 centimeters. Not a number I would have just thought of off the top of my head, is it? No. But we can just do a little bit of algebra and solve for it. It's not too hard, is it? Right? But you got to know the formula. That's the thing. Okay, especially in geometry, we'll be given some formulas from time to time, and give the formula, plug in all the stuff that they tell you, find what you want to, what they want you to solve for, and then you're good to go. Ready to move on to the last one? Everybody okay with this? Now it's time to ask questions if you have any questions. All right, let's do another one. This is part B, but it really doesn't relate to that circle. This one says, find the circumference of a water tower that measures 60 feet across. Now, what did they tell you, the 60 feet? What is that? That's the diameter, isn't it? Okay, if you measure it across, that means it's going through the center, okay? So the diameter across is 60 feet. And I want to find the circumference. This one's easier than the first one, okay? So what's my formula that has circumference and diameter in it? That's it. Circumference equals pi times diameter, okay? And look, you don't have to do any algebra or anything. All you do is just plug it in, right? So pi, I'll just leave it pi. I won't put 3.14 because I'm going to put that in my calculator anyway, okay? And then times the diameter, which is what? 60, all right? And there you go. So C is equal to 60 pi, or if you put it in the calculator. Now, let's do this. You do have a pi button in your calculator, right? And it goes out a whole bunch of places. But so that we're consistent, so we all are getting the same answers, let's always, every time you see a pi, let's always use 3.14. I put equals here because that's what we're going to use when we do pi on these problems, okay? So you do have a pi button on the calculator, and it takes it out, I don't know, 7 or 8 places, something like that. Don't use that button, all right? Because again, there's no way we can measure out 8 decimal places, right, with feet. There's just no way. So let's just use 3.14. That's as accurate as we need to be, all right? And if you do that, now, I don't even know if I did that on this example. Yeah, 188.4. Very good. 188.4. This is in, what did I say it was? It was in feet. So the circumference is in feet. Make sure you always put the units if they give you something in units. And that's what the answer is. Pretty simple, huh? Yeah. Usually the part A is easier and then the part B would be harder. This way it was the other way around. But I don't think either one of them was that bad, was it? No. Did I give you homework last night? 13 to 20? Is that what it was? 31 to 43? Okay. So we'll look. Well, we got 5 minutes. I'll give you the answers real quick after we finish this. So your homework tonight is 44 to 53. So it's page. I think the page number is right. Page 37. 44 to 53. Is that what I gave you on the lesson plan paper? Yep. Today's 21st. All right, so we'll call this section 16B. So the one you're turning in today is 16A. All right. So this is 16B. And that'll be due, what, on Monday? Yep. All right.